So we're going to create a solid this time, not by rotating, but we're going to still use the rectangle, but we've got to get a little creative here. So we're going to find the volume of this described solid. And what it is it has a circle for the base with a radius of 4, and then parallel cross sections perpendicular to the base or squares. So basically it's just a lot of little thin sheets of squares glued together. So if you can think about just gluing these squares together, it makes this solid. So what we need to do is find a fixed point that we can use to find all of them. So all of these squares share this circle. That's where we want to start. So if they all share the circle, okay, so here's a better circle. And this has a radius of 4. So we know over here would be 4, 4. That would be negative 4. And that would be also negative 4. For the y coordinate, of course. And so our formula for a circle is x squared plus y squared equals 4 squared. So we get x squared plus y squared equals 16. This is the equation for our circle. Now that we have a circle, all we have to do is think about how does that shape fit. So if I were to draw this like square, and obviously it's not a perfect square, but you get the idea. That's one square. If I can find one dimension of this, it's a perfect square. I can then use it to find the formula for it. So look at it. I can draw a rectangle here just like we've been doing. And if I do that, that rectangle represents a portion of one of the squares. So let's label it. That would be y equals and dx for this. Okay, and then how would that rectangle, that square translate? That square goes from here, the negative 4, all the way through the shape to positive 4. So if I draw that square now, just like we did before with the circles, and I place on it that little green portion right here, I can say that's my y equals. Well, look at my dimension. If that's y equals, well, then this over here would have to be 2 y's. So that means the area of my square, I'm going to put that in red, would then be 2y squared, because it's a perfect square. So it's length times length, length times width, however you want to look at it, but it's 2y squared. So I now have the formula for it. And look what I have up here. I have an equation for y. So if I come up here and I solve for y, in fact, all I need to do is solve for y squared, because down here, when I multiply it out, I end up with 4y squared. So now I can take that y squared from above, plug it in, and what I'm creating here is a formula that finds the area of every single one of those squares. So now if we check this, if I were to plug in negative 4, that square at the end would be 0. Because if you think about it, right at the tip there is no square. It's 0, right? It's a very, very tiny, it's infinitely small. It's 0. All right, so if I were to plug negative 4 in here, that would become positive 16 like this. So if I test it with an x equals negative 4, I would get negative 4 times 4 squared plus 64. Well, that's 0. And if you think about the 0 at the middle, if I plug 0 in, that's my biggest square, right? And you could even see its side length is 8. So that'd be 8 by 8, which is 64. So if I plug in 0, you get negative 4, 0 squared plus 64. It's 64. And then it works the same way if I kept going all the way across. So if I plug in any x value, it gives me the area of that perpendicular square. So now, if I take our normal formula, it's from start to finish. So negative 4 to 4. Let's actually write it out. From start to finish of the area dx. So our start goes from negative 4 to 4. That would be where our first rectangle is formed at negative 4, and it slides across to 4. Now we could also say we started at 0 and go to 4 and then double it. That would work as well. What's our area formula? Well, it's negative 4x squared plus 64. And how thick are these? Well, they're dx thick. And there you have it. So now if we plug that into our calculator, it'll tell us the volume of this solid. And so our calculator gives us, make sure it's correct, negative 4 to 4 of negative 4x squared plus 64, 341.33 or 1024 over 3. Now I'm going to use that one because I want it to be a nice answer. So 341.33 0.33, and this is now cubic feet. And you can see where it's coming from. Remember, this is feet and feet, so feet times feet is feet cubed, and then the thickness is another feet, so it's cubic feet. All this does is add up all those paper thin volumes. So we found the volume of that one sheet, and that one sheet, and that one sheet, and that one sheet. And the integral says, well, let's just add them all up from -4 to 4, gives us our volume. There you have it. So when you make these solids, just draw that shape at the bottom, try to figure out how your rectangle fits in, use it, and it'll tell you what it is. You notice there's no pi here because this is a this is not a circle, this is a square, so it's just length times width.